So in this module we are going to be dealing about impact of jet on a vertical plate, and the vertical plate we are considering here is a stationary vertical plate, and we are considering a jet of water with the velocity striking this vertical plate. So the initial velocity BV, since this is a vertical plate, after hitting it will get deviate, so the angle here will be 90 degree. So we have to find the impact of jet. Impact of jet means how much the jet of water exerts the force on this vertical plate. So in order to find the force exerted by this jet, we have to find in which direction the jet is kept, or in which direction the jet of water is being ejected. It is in x direction. That means we have to find the force in x direction. We all know that equation of force. Force equation is rate of change of momentum. Rate of change of momentum according to Newton's second law. We all know that momentum equation is mass into velocity. So change of momentum means what? Change of momentum means initial momentum minus final momentum. Final momentum. This is change of momentum. We have to find the rate of change of momentum. That means we have to divide the whole by time. So we can write initial momentum as mass into initial velocity minus final momentum as mass into final velocity and whole divided by time. In this, mass is common, so we can rewrite as mass, we can take it as common, and initial velocity minus final velocity whole divided by time. We all know that mass is equal to density into volume, so we can substitute mass as density into volume into initial velocity minus final velocity whole divided by time. Again we know that volume by time, discharge is equal to volume by time. So I can replace volume by time as discharge. So I can rewrite the equation as density into discharge into initial velocity minus final velocity. And again we have another equation, Q is equal to area into velocity. And area means area of the nozzle. Area of the nozzle, and velocity means at what velocity the water is being ejected. That means the initial velocity itself, or the velocity that is ejected from the nozzle. So it will here it is V only, so we can write as V. So we can rewrite the equation as density into area into velocity, and we have to find the initial velocity. Initial velocity here is V. So I can rewrite initial velocity as V, and final velocity, we shouldn't take this component. We are considering rate of change of momentum in x direction only. So x direction means after hitting there is no velocity component. That means in x direction the initial velocity is v, and after hitting the plate there is no final velocity, which means final velocity is 0 in x direction. In this direction only we have to consider. So since this is a stationary plate, there is no final velocity in x direction, so this component will become 0. So I can rewrite as 0. So I can rewrite the equation as rho into area into v square. This is the impact of jet on vertical plate, and we all know that area equation, area is equal to pi by 4 into d square, and d is the diameter of the nozzle.